Math time! Alright, good day, guys. Last lesson of this unit. Yes! And then we'll be 3 down almost. So today is lesson 7, where we're going to look at dividing polynomials by monomials. Okay, so last lesson we were looking at how to multiply. Now we're dividing. Okay, it uses a lot of the same steps and kind of distributive property. So what we're going to be doing, right, is we're going to be taking our divisor, so in this case 2x, and we're going to be applying it to both of the terms on top. Because this line, this division covers everything, we're dividing everything by 2x, okay? So one way you could do this, right, to simplify things is you can break it down into 2 terms, right? Minus 8x over 2x, right? Then all you can do is 6 divided by 2 is 3. X squared divided by x is x1, right, or x. Minus 8 divided by 2 is 4, and x divided by x is nothing. So we end up with our final terms, polynomial, as 3x minus 4. Okay, let's try another. So here, same thing, we can kind of split it up over 3x plus 6x. Classic. We're going to go down here. All right, 6x divided by 3x, right? This simplifies to 3 divided by 3 is 1. Okay, you can write that there if you want. You don't have to. And then x squared divided by x is x plus 2, right? You can even simplify this just to x plus 2, right? This 1 doesn't need to be here. It's mostly just a placeholder. We kind of imply that it's there if we have x, because there's at least one x, otherwise we wouldn't even be writing it. Okay. Same thing here. You could take a bit of a shortcut if you're starting to feel confident with this, right? So 8 divided by 2 is 4. X squared divided by x is x minus 2 divided by 2 and x divided by x. So really it's 0, right? So we can simplify this as 4x. All right, last one. Negative 2t divided by 2t is going to equal minus t, negative t, right? 4 divided by 2 is 2, t divided by t is 0, or t to the 0, right? Which, as we know, any term to the exponent 0 is 1, so we don't need to write that, because 2 times 1 is 2. All right, we're going to look at a bit of a word problem. So we'll read it out here. We're going to flip to the next page and go through it and solve. Okay, so for their Christmas banquet, the grade 9 students wanted to decorate the end wall of the gym with red poster paper. You guys are ambitious. The area of the wall is given by the polynomial 45x squared plus 20x. Whoa, whatever, Mr. B. That's just complicating things. One sheet of poster paper covers an area given by the monomial 5x. What polynomial expression represents the number of sheets of paper the students will need to cover the wall? Okay. So what we have is we're given a polynomial, 45x squared plus 20x, right? And we're trying to find how many pieces of paper. So if this is the area and we divide it by one of the sides, right? Oh yeah, one sheet of poster paper covers the area of 5x, right? So we can take our total area divided by the area of each piece of paper, and that'll tell us how many pieces of paper in a polynomial that we need, okay? So same thing here. We can go straight to dividing, or we can break it down into 2 components. 5x plus 20x divided by 5x, right? And this simplifies to 45 divided by 5 is 9. X squared divided by x is x, plus 20 divided by 5 is 4. X divided by x, we don't have to worry about, okay? So we would write a statement, they need, or you need, Mr. Grade 9s and Mrs. Grade 9s, 9x plus 4 sheets of paper. Ta-da! Okay. So one way you could also expand this if you want to have some fun is you say, how many sheets of paper if x equals 2, and then you can put the 2 in there. We're going to be looking at that more in the next unit, but that's something you kind of go forward. So I'll put a little star here if x equals 2, what is the number of papers needed? Okay, so that's a little challenge question if you guys want, and I can go over that with you in class if you want to know the answer. Okay, so the last thing we're going to be doing is creating another model of the division statement using using algebra tiles of 4x squared minus 8x divided by 2x. Okay, so we're going to scroll down a little here so we have some room. We're still going to make that kind of chart that we did when we were multiplying, but now instead of filling in this area, we're given this area. We're given one of the sides and we need to find the missing side. Okay, so here we're going to start with 4x squareds, okay, and they're all positive. And you always have to kind of fit them into the grid, right? So you can't have just like a one sticking out like a sore thumb because that wouldn't make sense. Okay, all of these are positive. So we're going to shade them in a little. Okay, minus x, 8x. So we have 8 x's, right? We're going to fit them into our nice little grid here. We're going to try and make them as scaled as we can, or as similar to one another. Not always going to work out perfect. Okay, and these are all negatives. Then we're given one of the terms, 2x, okay? And we're given the fact that this is positive, right? And we know it needs to go on the side because we made 2 rows, right? So if we had 2x, there can only be 2 rows in our area model. And then it's up to us to figure out what are the missing pieces. So I have x squared, so I know I'm going to need some more x's, okay, to make this grid work. And because this is positive and this is positive, we know this needs to be positive. It's the only way we'll get a positive answer here. All right, and then to finish it up, these are only 1 unit blocks wide, so we'll fill those in first. And then we'll determine if they're positive or negative. Well, here we have a positive, here we have a negative, so we need a negative in order for this to be true. Okay, so then all of those are negatives, and we're good to go. All right, that's all I have for Unit 3. I'm going to ask that you guys do some practice work on page 275, questions 4, 5, 8, 9, 10. All right, have a great day. Mr. B signing out.